When we look at a scene, we can't always tell how far away objects are. Our eyes, well, at least my eyes, are not laser scanners. They don't return z-depths directly to my brain. Maybe another way to say it is that we're not bats and don't use sonar. Our eyes detect what is called the radiance coming from each direction. Our brain figures out distances from a variety of visual cues. We're not even particularly aware of these cues. For example, it wasn't until the Renaissance that painters figured out that distant mountains had a blue tinge, and so started to paint them that way. However, the actual amount of light from those distant mountains is a given amount of radiance. We don't store a depth. One way to think about radiance is in terms of a function called the light field. The idea of the light field is that for any point in the universe, and for all directions from that point, there is an incoming radiance value that we can record. Say we're sitting at a desk. For our location, we can look around and see a color in any direction. In computer graphics terms, we're recording a radiance for each different specific direction we look. To form an image, we find the radiance coming through each pixel. Imagine we have a sensor floating in space that can move anywhere and look in any direction. I like to think of the sensor mounted on a turret with the turret rotating as needed. The question to you is how many numbers, how many variables do we need to specify our imaginary sensor's location and direction so that we can record the light traveling through any point in the universe from any direction?